It's Mr. Wilson here, and now we're going to take a look at perpendicular graphs. So, this is a normal straight line graph, and we could be asked to say, write down any equation that is perpendicular to it. So, first of all, you need to understand perpendicular means at right angles. And if you have a graph like 2x, let's say it's like this, to make it actually perpendicular, like so, you can see it's not the same steepness. And it's also going in the other direction. So, what is actually happening to this steepness is it's being reciprocated, or it's the inverse. So, if this is 2x, what this one actually is a half. Imagine 2 is written like this. I can simply flip them over. And if this is a positive gradient, this one's negative, so it has to be minus. So the gradient would be minus a half. So for this one, it would be minus a half x. And then, I'm not going to worry about a number. I could put a 3 there, but I can actually put any number, because just moving this up and down this line doesn't make a difference. It's this bit that we're interested in. So, if it hasn't got a fraction, what I like to do is just put the fraction in. 2 divided by 1 is still 2. Reciprocate it and change the direction. So here, this is the gradient part, the bit with the x, not the bit without. This is the y-intercept. So it hasn't got a fraction, so I'm going to introduce it. This is negative, which means it's coming this way. I need to make mine go the opposite direction. So it's going to be a positive, and I'm going to reciprocate it, so it's going to be 1/3. So 3 over 1 reciprocated is a third. The minus is now positive to make sure it goes the other way. Now, if there's already a fraction, it's maybe sometimes a little bit easier, because you can just reciprocate it. Oh, there should be an x there. So it's 2 over 3. And I need to change the direction. So 2/3 is still positive. I need it to come steeper. Oh, I've just written the same thing again. 3 over 2. And the opposite direction. It says minus, but I'm going to put a plus. Like I said, it doesn't matter. The y-intercept just moves up and down. It's the perpendicular gradient that I'm interested in. So always reciprocate it. Now, that's an easy question. Let's have a look at this. So, what is the equation of a line that passes through? So I have covered this previously, but let's do it again. I like to make a very quick sketch. So minus 2, 8 would be 2 along, 8 up, somewhere along there. This is not to scale at all. And this one is 3 along, 7 down. So I know that this gradient is going to be negative. I know my formula for gradient is the difference in y divided by the difference in x. The difference in y here is 15. The difference between these x values is 5. 15 divided by 5 is 3, but because it's in the negative direction, I know it's negative 3. So what I've got at the moment is this. Now, most people like to substitute in. It's much easier if you don't, but I'll substitute in. So we've got 2 coordinates. Let's just use this one. And because we have an x value and a y value, I can just swap them over, substitute them in. So y is 8. So 8 is minus 3 lots of minus 2. So 8 is 6. 6 plus something is 8. So that something must be 2. So the equation of the line that goes through here is y equals minus 3x. It's got a negative 3 gradient and a y-intercept of 2. So that would be 2. Now, it says write the equation of the line perpendicular to this answer, and it passes through 0, 3. So, I'm going to write this again. So, perpendicular simply means, like I just said, make it go the other direction, so it's not going to be a minus anymore. It's positive. I'm going to reciprocate this number, so I'm going to swap them over, so I have 1/3 of x. So for both of these, that is still the gradient. Now, this one is dead easy. 0, 3, if you think about on a graph, 0, 3 would be there. It's a y-intercept. So I just put the y-intercept on. But here, 6 minus 1, that isn't a y-intercept, so I'm going to have to do a little bit more. So I don't know what it is straight away. But I do have an x value, and I do have a y value. So, minus 1 is 1/3 of 6 plus c. Tidy up. 1/3 of 6 is 2. Get c on its own, subtract 2. So c therefore must be minus 3. So the equation for this one would be 1/3 of x minus 3. And this is the same for the parallel graphs. Obviously parallel, you keep the gradient the same. Perpendicular, you reciprocate it and change the direction. And that's it. That's the highest standard of straight line graphs.